Hi, I'm Keith Graham from Codasip, and I would like to demo the very first assignment that you will do in either your computer organization or computer architecture course. It'd be assignment 1, checkpoint 1. I've now entered Codasip Studio, and you can see that I've already previously imported both my assembly project, which is the assignment 1 program, as well as my processor project, IA RISC-V32. So the first thing you will be asked to do is to modify your assembly program. Remember, this assignment's goal or objective is just to teach you or show you the different perspectives and how to manipulate files and run different parts of the application of Codasip Studio. So let's go modify our assembly project, which is the first thing you must do. So go to the File Explorer window. Now within that window, I can expand my assembly project, expand my source folder, and now I can see my assignment 1 test.s file. A .s file specifies an assembly program, a .c for C program. So I'm going to click it once, and my assembly program will open to my right. Now, the first thing we're asking you to do is add your name, because you will be the author of this software program now. So for me, that is Keith Graham. And then we want you to come down on line 14, replace the F for first initial with your first initial, which for me is lowercase k. And then for line 16, replace the L, which signifies last initial, with your last initial, which for me is G. Now, once I've made those changes, I need to go save it. So I'm going to go up to File. You can select either Save or Save All. Since I'm only modifying one file, either one will do achieve what I want to do, is save this particular file. Now, with my modifications now in my assembly program, I need to go compile it. So let's go to the test flow perspective. In my test flow perspective, before I actually compile, the first thing I need to do is develop my software development kit, which will be created from the model of a processor, the IA RISC-V32i. So I'm going to expand that project in my test flow perspective. Click on Generate Software Development Kit, and the particular tools that we want to generate are in the IA model, instruction accurate, so I'm going to click on that. This build to generate the IA model takes about 3 minutes, so I'm going to pause the video and I will be back shortly. My software development kit is now built, and you can validate that 3 different ways. The first way is by looking at the Task Generate SDK window at the bottom. You can see that it actually says Build Finish. Another way is I can go to my Perspective toolbar on the left, click on Codasip Tools, and it will bring up a list of all my tools that have been built. You can see that they're all check marked, which means that they have been built. Sometimes after a very recent build, you might have to refresh the screen to actually see that they were actually built. So just want to let you know about that. If you don't have the Codasip Tools perspective, go up to View, Open View, and then click on Codasip Tools, and it will add it to your perspective toolbar on the left. Now, the third way is going back to the workflow perspective, expand your assembly program, and the very first task is Assign SDK. I'm going to click on that. And when the dialog box comes up, if there's nothing underneath it, it means that there's no SDK. I can't assign an SDK because it doesn't exist. Now, since I can assign an SDK, then I know that it's been built as well. So I'm going to assign it to my project, and I can validate it that it's been assigned by expanding Assign SDK. And you can see that my RISC-V32i project is my SDK or software development kit for my assembly program. Now the next thing to do, it's a workflow. So workflow means I'm going to have a flow of work. I've assigned my SDK. The next thing is to compile it. Now, since it's an assembly program, we have to do something special in the compiler configuration. Now I'm going to go to the cog on the right of compile, which will bring up the compile configuration window. I need to select no startup or default lib. When you compile a C program, it will append in front of your file a particular program that will prepare your the system variables such as your stack pointer before you enter your C program. We are not using those system variables in assembly programming, so we need to disable that appending onto your project. Now I'm going to hit save, and I know when the compiler configuration has successfully saved when the window closes. Now with the save completed, I can now click Uncompile. You can see in my task compile window on the bottom here that I have successfully compiled 100% build target main.executable. Looking good. Now I'm going on my workflow. I don't want to run the program. I want to go into the debugger. So I'm going to go to the debug configuration window by clicking on the cog to the right of the launch debug. And it's always best practice that you want to have your program automatically stop someplace every time you launch a program in the debugger. So I'm going to say stop at startup, and I want to stop after in instructions. And I'm going to say after 0, which means that I'm going to stop as soon as I enter into the debugger. Now, if I wanted later on, I had this large assembly program, I might say stop at 100 instructions. And if you're in a C programming, you probably will want to say something like use the stop at a function, which might be main or some other subroutine call. I'm going to hit save. Similar to the compiler configuration window, I know when it's saved completely, when it closes. Now I can actually launch the debugger. And you can see that once I click on that, I will have to specify which program I would like to debug, which is my assembly program. And it will automatically switch me to the debugger perspective. Now you can see that I have a single thread here. That thread actually signifies a debug session. So I have one debug session going on. If I come down here, you can see that this is a call stack, and it's going to provide a lot more detail later on when we look at some C programs. But for this assembly program, the key thing to look at it has this number 14 at the end, which corresponds to the line item in my assembly program that I've stopped at. So I've stopped at line 14 of my assembly program. If you notice, that is the very first instruction of my assembly program, which I specified in my debug configuration. Now, I can put a breakpoint by putting my cursor to the left of a line item. It might be tough to see, but it's very dampened or low, not very vibrant red circle, but when I click on it, it becomes vibrant. That means I have a breakpoint. You can see the breakpoint also is specified in the breakpoint window. I can disable it by unclicking it or enabling it by clicking it. Now I can automatically go to line 16 by clicking resume. And I can do one step at a time by doing step over. Step over is more of a function that I use when I'm doing C debugging, or step into. So these are different things that you can actually do in the debugger. Now this debugger, I'm going to put a halt, a breakpoint at halt. Down here you will see that it's asking you to record some information in particular registers, X3, X4, and X5. This will be part of your assignment. So I'm going to just do a resume all the way to the halt, which is my breakpoint. And now to get those values of X3, X4, and X5, we need to look at the register values. We can do that by looking at this window down here called registers. In my debug perspective, I use these all the time. So I'm going to move them up to something closer to the top. And I just click on registers and drag it up and to whatever other window that's highlighted. When I release it, the registers will be inserted right above that. Now there's two sets of registers. There's some microarchitecture registers, which are registers that are in an actual physical model, your cycle accurate. We're not doing the cycle accurate right now. So what we really care about is the architectural registers. Now the architectural registers are registers that the programmer can see, such as the program counter and all the general purpose registers. So I'm going to expand it, and you can actually see the different registers down here. And you can see there is a value for X3, X4, and X5. Now I'd like to show you a little bit more about the debugger. So I'm going to actually terminate this session. You can actually restart your debug through this shortcut up here, where I can say start the debugger. If we had more than one program here, I could select a different program to debug through this shortcut as well. So I'm going to start another debug session. Like the previous one, it stopped at as I entered right here. And now I'm going to actually single step. And you can see this line 14, what it did was add immediate, which is really just adding the value of K into register 4. So you can see there's a value in register 4. This next instruction says shift logical left immediate by 8 bits. So shifting a value to the left by 8 bits is like inserting 8 zeros to the right of a particular number. So I'm going to step over that, and you can see that the value in X4 is now shifted over by 8 bits, just like the assembly instruction. So this is how you will interface with the debugger for a lot of different projects that you'll be working on throughout this course. There's one more thing I'd like to show you before I end this video is how to submit your assignment. So this assignment requires you to submit the modified assembly program with your name as the author and your updated first and last initial. To do that, you will want to go to the File Explorer perspective, click on your assembly program, and then right-click it, and then you can go select Download, and then you can download your file and then submit it for submission. Hopefully this video is helpful.